So let's start over here. So these are some symbols for electrical for circuits, right? So which you should know, right? Like this, can we draw wires as this? If you want to draw a wire, just a straight line. If you want to show that two wires are connected together, you basically have to draw. Let's say this is wire one, this is wire two. So you want to draw a dot, which is basically shade over here, right? Which means it is connected together over here. But if there is no dot here, it means that the wires are basically just over crossing over each other. They're not connected together, right? The cell is just a single, basically plus minus terminal. You want to draw a battery, it is connection of cells in series, right? It becomes a battery here. It's a switch here. So these are important terms which you should know, right? And ammeter, we have seen this before, right? And lamp is shown as this. We have seen voltmeters, right? And this is a fuse, which basically contains a box and contains a wire crossing through it, right? It's pretty similar to resistor, so don't confuse yourself with this, right? Fuse has a line passing through the box, right? And we have also seen variable resistor here, right? So it has a resistance which can vary. So these are symbols which you should basically know and learn them for basically using them in your questions, right? Because these are the ones which you will be using multiple times, right? So I hope it makes sense. These are the symbols, and let's move on to see now some combination of circuits, right? We can have connections of components in a circuit in series or parallel, right? Can anyone just share okay, what will be the series connection over here? Let's say if I have a battery, if I have a lamp, and if I have a resistor, how would I connect them in series? Anyone? Any idea? How would basically you be arranging the component in series over here? It's simple, right? You just basically connect them in one loop, right? Let's say this is a battery here, right? And this is the lamp here, right? And this is the resistor here, right? So in series means that if you basically if the charge tries to basically take a round, it has to basically go in a single loop, right? So it's a series connection over here. This is a resistor over here, it's a lamp here, and it's a battery source here, right? So what is this special property of circuits which is a series circuit over here, that the current flowing through the circuit, let's say this is point B, this is point C, right? And this is point D. So if you measure current at B, C, and D, the current is going to be same, right? So current is same throughout the circuit in a series configuration here, right? Okay. So if you see this over here, this is again the same topology here. They have created basically a battery using two cells, right? This is a battery here, and they have placed two lamps in series with an ammeter also, right? So they're saying if you measure current throughout the circuit at any point, whether this point, whether this point, whether this point, this point, or this point, or this point, right? The current is going to be same, right? This is the property of a series circuit here, right? So let's skim this theory thought about what are they saying over here. In a series circuit, which is basically shown, you can see this also, right? Different parts follow one after the other over here. Okay, there is just one path for the current to follow. The reading on ammeter will be same whether it is placed on position B, C, or D. That is, current is not used up as it goes around the circuit, right? So current remains same over here. Just imagine if you are running, right? If you are running in a ground, right? Right? You start from here, right? And this is point A, B, C, D, right? So to complete the loop, you can only take this path, right? Right? So you only basically go in one loop over here, right? Therefore, you can just imagine this. This is similarly the current here, right? Current is moving throughout the circuit over here. It goes in only single loop over here. That is, it has no different multiple paths to follow. It has only a single path to run through. That is basically the wire over here, the series connection over here. And this basically property leads to that current remains same throughout the circuit at every node, right? So if this makes sense, give me a thumbs up. This current configuration in a series circuit. That's good, right? So now I'm gonna basically learn that what happens in a parallel circuit, right? What happens in a parallel circuit. So let's see. Now we have a parallel circuit here. We have seen this in the last lecture also. So it's going to be a summary, right? You have a cell over here and you have an emitter placed and you have two lamps, lamp Q and lamp P placed parallel to each other, right? So you can imagine that the current comes over here, right? Current flows from positive to negative, right? And then at this node, it sees that it has, let's say this is node B, and this is node C. So at node B, it sees it has two direction to pass through, right? So the current is going to divide here, right? And we have seen which law does that. It is a Kirchhoff's current law, right? And similarly, I1 flows through this, and I2 is flowing through this wire. So after they cross C, then they merge up together to basically form I back over here, right? So again, the current reaching back to the battery or the cell is I, and the current exiting to this from the cell is I, right? So this is basically Kirchhoff's current law, which we have seen in the last lecture, right? Which makes sure that the total amount of charges flowing through the circuit are conserved, right? This is the Kirchhoff's current law, KCL, right? So over here, we have this property over here, the current divides up. If you can just imagine, okay, let's say this is uh, a ground here, and you can reach, let's say this is another part of the ground, can reach through 2 points, right? We have two tracks to reach. This is, let's say, point D, this is point A, right? So let's say we have two-person current, basically, let's say we have a person in here, and he has a miracle, right? Let's say he can divide his personality into two parts, right? So as soon as he reach this particular node, okay, he basically divides himself into two equal parts. He becomes smaller, right? And then after he crosses this node back here, he becomes normal again, right? So you can imagine that these are this is the current over here. These are charges over here, total charges. So some charges divide in these two loops and they basically come back together when they reach point D here, right? So this is just what is happening over here when the current sees multiple paths to flow, right? And one other special property in the parallel circuit is what? You can see something else also over here. Let me just duplicate this slide and go to the next slide. So you can see something also over here that the battery, let's say, has a potential V, right? It has a EMF V. So you can see that this lamp also connected to this particular point that is directly connected towards the positive terminal of the battery, right? And this terminal of the other lamp is also connected with the negative terminal of the battery directly, right? So we learned this law in the last lecture also that the components in parallel have the same potential, right? So this is also will have a potential V drop here, and this lamp P is also having a potential V dropped here, right? So what is the rule here? That voltage remain same in parallel configuration, right? Does that make sense? If that makes sense, give me a thumbs up. The how do we connect components in parallel? ठीक है, makes sense to me. What about others? ठीक है, so if you want to connect them in parallel, they basically connect side by side, right? What about Hamza? Hamza clear है? Okay, good, right? So you see differences over here, right? What is happening in series and parallel, right? So this is a summary of the discussion which we basically learned in the previous slides. Okay, in a series, circuit components connected one after another. Current is same in each component, right? However, in parallel circuit, components are connected side by side and current splits into alternative paths and then recombines together, right? Which we have seen over here, right? It basically divides and then combines together, uh, backed at the node C here, right? So let me write down the equations here. So if you want to write down the equation over here, the KCL equation, which we learned that in the last class, that sum of current entering is equal to sum of current exiting, right? This is a node B. इसके अंदर current कौन सा enter हो रहा है? That is I, right? It is entering the current node B here, right? So we have I is equals to current exiting, that are I1 plus I2, right? This is the equation at this particular point, right? What about this particular point? At point C, we have this equation that I1 and I2 are entering the node here, and current exiting is basically I, right? So you can see that in both the sides we have I equals to I1 plus I2, and here we have I1 plus I2 equals to I, right? So the charges remain same, right? The conservation of charge law, which we'll see in a while, we'll derive this law in a while. It basically makes sure that the charges are conserved over here. That you can imagine here, let's say if 500 charges are entering this particular point B, so this would be dividing into, let's say, 250 charges here and 250 charges here, right? In I2, right? So the total amount of charges flowing in the circuit remains same, right? Charges, because we have the law that charges cannot be created nor destroyed, right? So we have to make sure that charge is conserved, right? Okay. Now current in a junction over here. So let's revise quickly what was the KCL which we learned in the last lecture, right? KCL basically stands for Kirchhoff's current law. Some say Kirchhoff's, some say Kirchhoff's, some say Kirchhoff's. So I prefer Kirchhoff's, right? Kirchhoff's current law. Okay, you can learn this as KCL, right? What do they say, right? It says the following thing, that current, sum of current entering a node is equals to sum of currents exiting a node, right? You can also basically transfer this into a definition by just basically just converting the symbols into a definition, right? Okay. So what does this symbol means? It means summation, right? You're adding all the currents together, right? Let's see an example here. Let's say you have this example here, which we have seen yesterday, right? This is node A, right? Node क्या होती है? A point, right? It's a point. So this currents are entering over here. This is I1, right? This is I2. This is I3, I4, I5, right? I3, I4, I5, right? So what does this law says? कि it says कि जो current enter हो रहे हैं, sum them up, right? And it is equals to the sum of current exiting, right? So this is basically the conservation of charge law here, right? Conservation of charge. It basically is derived from conservation of charge law over here, because it says here, if let's say 1,000 coulombs of charges are entering this particular node A, then 1,000 coulomb of charges should exit, right? Because current, the charge cannot escape, cannot basically blindly escape from the existence of the universe, right? So that is why it is basically applicable in every circuit over here, right? This is the basic principle over here. So let me just insert a slide. So what do we have now? We have that current entering are basically I1 and I2 over here. So the equation is going to be I1 is equals I1 plus I2 is equals to, and what are the current exiting this particular point A? What currents are basically exiting this particular point A? This is exiting, this is exiting, and this is exiting from point A, right? So let's sum them up, right? So this is the Kirchhoff's current law, right? So you can also apply this, which we basically applied this also in the last question at this node, right? If you can recall, we applied Kirchhoff's current law over here, right? So we use that current entering equals to current exiting over here. Similarly over here, right? This will help you to solve questions. Okay, when you have parallel circuit configuration. We'll do a question in today's class also, which will explain okay, how that you're getting used over here. Right. So if KCL makes sense, give me a thumbs up. If KCL makes sense, this particular law makes sense. That makes sense to Hamza. What about Vardha and Maeve? Okay, it makes sense to Maeve also. Vardha, are you here? Okay, ठीक है. Good. Now we have potential difference in a series circuit. Imagine that we have this circuit, right? We have a battery, right? And then we have resistors in series. Let me keep it simple to just two resistors, right? We have the battery potential at V. This is the current flowing through the circuit. I comes back to the negative terminal. This is positive. And we are basically placing voltmeters to measure the voltages across these resistors, right? We want to basically make a connection with the wire. We want to draw dots here like this, okay? Make sure you draw dots, which shows the connection आपके हुए में with the wires, right? So this is R1, this is R2 here, right? So if you want to basically want to find a relation. Let's say the voltage drop across this resistor 1 is V1. The voltage drop across this resistor 2 is V2. We want to find out the relation that what relates basically the potential of the battery and the potential difference dropped on the resistors here, right? And if you recall the last lecture, there's one another law which we learned in the last lecture, which was the KVL. So KVL basically applies here, right? So what does KVL say stands for? KVL stands for Kirchhoff's voltage law, right? And the short form for this is basically KVL. Can you tell me what is this formula here? What is the definition of this relation of this law? We had done this basically yesterday, so I believe कि आपको याद होगा. And you all were there in the last lecture. What does KVL stand for? Anyone? I want an answer. Jilly se. What is the rule for this? Okay, I have a chart here. Together in one line. Yes, it was correct, Vardha. So now, what was the KVL law? Can anyone just tell the definition over here? What was KVL? Hamza, बताएं आप. What was the KVL law which we learned yesterday? You have the circuit in front of you. It's everything in front of you. It's pretty simple. I can hear you, Hamza. Yes. Hamza, I can hear you. Yes. Speak up. Hello. Okay. So basically, KVL was I have a comment here. I don't remember. Hamza, कल ही पढ़ा आपने. So always try to revise the slides before coming to the lecture. ठीक है? Okay, I have. ठीक है. So it's pretty simple. So it is basically saying the following thing, right? It says the following thing, which is that sum of EMF is equals to sum of potential difference, right? Up which thing is producing EMF? So EMF is basically only for the batteries, ठीक है, or the cells, and which basically consumes potential differences, all the other components, ठीक है, which include resistance, lamps, ठीक है, diodes, thermistors, LDRs, so on and so forth, right? So these are basically known as sources, right? And these are normally called as consumer, right? They consume the voltage, right? So in this circuit, if you just recall, so you can see that the source which is producing, which is pushing the charges to move is only one, that is V. And the thing and the component which are consuming the energy and converting into heat energy are two, right? Which is basically this and this one, right? So the question comes out to be as follows. Therefore, we have this relation here that the, the question is the sum of EMF, right? That the if you add all the voltages of the batteries, that will be equals to the sum of potential differences. That is, if it is the sum of all the drop across the circuit components, which is basically taking place, right? And this says that it is V equals to V1 plus V2, right? And this formula basically follows what? It follows conservation of energy, right? So there might be MCQ in your question. K will follow with conservation of charges or energy, right? So it follows conservation of energy. Why? Because this battery is basically producing energy, right? It is providing energy for the charges to move, right? And this energy is getting lost here in terms of heat, right? So energy loss is taking place here. So in a basically, if you can imagine the conservation of law of energy, that energy cannot be created nor destroyed, but it can change from one form to another form, right? So this is the law here, that energy cannot be, we had learned this before also in Warden, right? In Warden power energy. So it is energy cannot be created nor destroyed, but it can change from one form to another, right? This is the conservation of energy, right? I hope it makes sense. This is not so difficult here and should make sense कि हो क्या रहा है यहाँ पे, ठीक है? So if the KVL, if the potential difference in a series circuit makes sense, give me a thumbs up. Okay, it made sense to me. What about other kiddos? Okay, it made sense to Vardha. Hamza, be quick in responding. Jaldi, jaldi. जी सही है. Good. Actually, now what if we have a parallel circuit, right? We have already learned this के parallel voltage means same, ठीक है? So again, let's for the sake of formality, let's do it again. So we have again a battery source, right? And now let's say, let me make complete circuit here just to basically show off my skills, right? So we have an ammeter here. Ammeter is always connected with the positive of the battery, right? And then we have a lamp here, right? And then this particular is connected to the lamp here. Then in parallel, I have another lamp here, all right? So this is lamp P, this is lamp Q, okay? And I'm measuring the voltage across this using 2 voltmeters, right? This is voltmeter V, all right? And this is voltmeter for lamp Q, all right? So this is the potential difference, but the EMF of the battery is V, and we learned that this is the two nodes of the battery. This is the positive node, this is the negative node of the battery, right? Because it directly goes towards the positive plate of the battery, and this directly goes towards the negative plate of the battery. Okay, जी? So you can see that these two components, lamps, are connected with the same poles, same basically wires, nodes here, right? That is positive, negative. Therefore, they're gonna have the same potential difference across them, right? So voltage drop in of a parallel component is same, right? So the voltage across P would be V. The voltage across lamp Q would also be V, right? However, the current would be dividing, right? Which we have seen in the previous lecture that if we have current here, the current basically splits over here. However, the voltage remains same, right? In parallel circuit, right? So this is the relation over here that voltage in parallel circuit remains same. ठीक है. This is just a formality and just a recap which we have done before, right? Now it's a very interesting point over here that how do you create batteries? How do you create basically how do you arrange cells to create batteries of your desired EMF, right? So let's quickly do this. So battery basically consists of two or more electric cells. And what is an electric cell? This is a cell over here, right? Which contains only single, basically positive and negative plate. This is a cell here, right? So if you combine two or three of them together in a certain configuration, it becomes a battery, right? So greater EMFs are produced when cells are joined together in series. We will learn that how do we produce greater EMFs over here, right? Uh, Now let's see how do we do this, right? Let's see this diagram here, right? So we are trying to make, we have a single cell of 1.5 volts. We have a single cell of 1.5 volts, right? Let's say I want to make a battery of 3 volts, right? How would I arrange them? Okay. I would basically arrange them in this particular configuration here that I have a positive, negative, and then a positive and a negative here, right? So if I have alternating polarity of the batteries, so the combined EMF of these two cells will give me basically what? It will give me a battery of voltage of 3 volts, right? So, but what if, acha, why do they add up if I put this in this configuration over here? Because if you recall, the current basically goes out from positive, right? So यहाँ से current इस तरफ direction में जा रहा होगा, यहाँ से भी direction इस direction में positive push हो रहा होगा हमारे पास. So the push of the cells are in the same direction. Therefore, their pushes would add up together and produce a greater EMF that was going to be 3 volts. That means here now they are basically they're pushing the charges in the same direction with the equal forces, but multiplied by 2, right? Therefore, you have a battery of 3 volts, right? If this point makes sense, give me a thumbs up. How is it 3? Why is it adding up? Okay, it makes sense to Hamza. It makes sense to me. That's good, right? Now, simply now imagine if I flip the polarities, right? If I positive here, negative here, positive here. So this basically is trying to push the charge in this direction. This cell is trying to push the charge in this direction, right? So now if you want to find the overall charge of this configuration, so it would subtract, right? It would be 1.5 minus 1.5, 0 volts, because they are opposing each other, right? This is trying to push the charge in this direction. This is trying to push charge in this direction. So they're opposing their effects, and they have the same potential EMF for each cell. Therefore, there would be no motion of the charges, and the current flowing, the overall basically EMF, not the charge. Overall EMF of the battery in this configuration is going to be basically be 0 volts. That means it is not going to push a charge to move around, right? सही है. ठीक है. So what is the rule here? If you basically have cells in this configuration, right? This is V1, this is V2, this is plus plus. So if you want to convert this into a single battery and want to find out the overall V of this V battery, so that is going to be simply V1 plus V2, right? This is case one. Now, if you have basically case B, if you have batteries in this configuration, if you have similar poles pointing towards each other, right? And this is V1, this is V2. Want to convert this into a single battery. Let's say if you are saying कि हमारे पास single battery बनेगी है. So इसका जो basically magnitude निकलेगा, that would be as follows, that Vp is equals to V1 minus V2, right? This is the formula here, right? Now we also have configuration number C here, right? What can you see over here? You can see that I have two same cells in parallel, right? What is the benefit of this, right? The benefit of this is basically is going to last longer, right? This battery lasts longer. You can imagine why. Because this cell is going to give you I1, okay? This cell is going to basically give you current I2. and this combined current is going to where the circuit here, right? Okay. And if you just let me just draw in another slide here. Just imagine if you had only single cell, right? And you had a resistor, right? Okay. This is 1.5 volts, and this is a resistor here, right? And this is a current which is going to be feeding the resistor, right? So now, if you basically go towards configuration number C, now you have two cells basically in parallel, right? Let's say current required was zero point 0.5 amps. Okay, let's say. Okay. Now you have placed the batteries in parallel with the resistor here, right? So in parallel, you know कि sir voltage तो same रहेगा मेरे पास because of the rule कि if it is 1.5, it is 1.5 volt in parallel. The resistor is getting 1.5 volt also, ठीक है? But what would happen to the current here? That is important point here, right? So this resistor still needs basically zero point 0.5 amperes to operate, right? ठीक है? Because we know from this configuration here, right? But if you have two cells in parallel, this would basically lead towards division of current. Now this cell would be providing 0.25 amperes, right? And this cell would be providing 0.25 amperes also. Because of KCL, if you see at node A, the equation becomes what? I1 plus I2 equals to I, right? So the current required is basically now shared by the two cells over here. Therefore, these cells would last longer as compared to a single cell, basically which is giving zero point 0.5 amperes, right? So this is the benefit of basically having cells in series over here, right? So now we're gonna basically derive some formulas for resistor in series, right? So we have done this in detail in the last class, so I'm gonna just do it as a recap, right? So let's imagine that you have this circuitry here, right? You have a battery, right? And then you have R1 and you have R2, right? This is a battery here, this is R1, this is R2, right? What is the goal? The goal is basically to convert this into a circuit in which I can solve it out easily and find out the current flowing through a circuit, right? So the goal is to convert this circuit into this form, right? The goal is to convert it into this form, R equivalent, right? And over here, now I know okay, I can simply apply the Ohm's law, right? To find out the current, and my current is going to be what? It's going to be simply the voltage of the battery divided by the R equivalent here, right? So this is my goal here, right? This is my goal here, which I want to do. ठीक है जी. अब we have seen the KVL, right? We have seen the Kirchhoff's voltage law, right? And according to KVL, I can apply a single rule here. That means that is basically what? That is K sum of EMF in the circuit. That sum, if you sum all the battery or the cell voltages in the circuit, they're going to be same as the sum of potential differences. That is the potential dropped across all the components which are consuming energy, right? So over here we have only one source, that is this battery here. So we have V equals to, let me call the voltage drop across R1 as V1. Let me call the voltage drop across R2 as V2, right? So it's going to be V1 plus V2, right? And we have also learned in this particular lecture that current in a series circuit remains same, right? So current throughout every component R1, R2 going to be I, right? And V is what? V is the equivalent basically voltage over here. Okay. So in this, I'm going to be using R equivalent here, right? So let's now just put in the Ohm's law here and to get our results. So V is what? Simply current is going to be same times R equivalent because this is going to give you the total EMF of the battery is equals to V1 is what? It is the drop across R1. So current through R1 is I. The value of R1 is R1, right? Plus now the voltage drop across V2, right? So now we can take something common here that is going to be, now this is just revision for you, right? So I hope okay, now it's going to be pretty simple, right? So what is common over here? We can see that I is common over here. So I R equivalent is equals to I R1 plus R2, right? This and this cancels out. Therefore, you have this formula for resistors in series. That is R1 plus R2, right? Hence shown. This basically the mathematical operation which says ke you have shown the equation over here, right? Proof is basically ended over here. Acha Ri, uh, acha again, what is there might be a question ke this resistor in series follows what? Conservation of charge or conservation of energy. So you just have to basically answer that what does KVL follows? KVL follows conservation of energy, right? ठीक है, so make sure to this pointers also, ठीक है, so these can get you 2 3 extra marks, ठीक है. This is basically the rule for resistor in series. Now let's say if I have a chain of resistors in series like this, dot 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 dot, this is R1, this is R2, this is R3, and this is Rn. Rn can be anything, 100, 99, 54, 2, something else, ठीक है. If you want to find the equivalent resistance of this combined array, ठीक है, that is going to be simply what? Just add them up. Right? That is R1 plus R2 plus R3 dot dot till the end resistor over here. That is the Rn over here. Right? This is the resistor in series relation here. Right? Now let's start resistors in parallel. Right? I hope that was clear. If you have questions, you can raise your hand and ask. Right? So now what do we have? We have now resistors in parallel circuit. Right? So we have this battery here. We have R1 here, and then we have R2 here. Right? This is point A. This is point B. Right? And this is the battery which has EMF V. And if you can imagine, if you can recall the last set of lectures, that in parallel the voltage remains same. So the resistor 2 is also having a drop of V, and resistor 1 is also having a drop of voltage V, right? But if you recall the Kirchhoff's current law here, the current that is sent by the battery is now going to divide into two parts, right? That is I2 and I1, right? So this is a question which we can use to derive the relation for resistor in parallel here, right? So what rule will we follow in this particular derivation? We follow KCL, right? And this is basically, this holds the conservation of charges law, right? Conservation of charges. Okay. And what does it say? It says that I is equals to I1 plus I2, right? Again, we can take help of the Ohm's law here, right? So what is my goal? My goal is to convert this circuit into a circuit which is containing only a single resistor of value R equivalent, so that I can simply find out my unknowns here, right? Right? This is I and this is V, right? So I want to find, this is my end goal here, right? So now again, take help of the Ohm's law. Now I want to basically make I subject. My I is going to be V over R, right? So total current is going to be what? If you basically see this circuit, if I want to find the total current, so that is simply going to be using my R equivalent value here, right? For total current, I need my R equivalent value here. Therefore, total current is going to be V divided by R equivalent. It's going to give me the total current flowing through the circuit is equals to, now I want to find the current flowing through this branch, right? So the voltage drop across this branch is V since it is in parallel with the voltage source, and the value of the resistance is R1, right? So if I want to find I1, it's going to be voltage drop across R1, that is V divided by R1, that is the resistance of this particular branch, right? That is how you find out these unknowns. Okay. Now I want to find out the current flowing through this branch, right? How would I find it out? I basically wanted the voltage drop across this branch, that is V, and the resistance of this branch, that is R2, right? So that's how you can basically find out I2, right? So it's going to be plus V upon R2. Now I can see that there is something common here, okay? So I can nullify that particular common thing. So it's going to be V 1 over R equivalent is equals to V 1 upon R1 plus 1 upon R2. This and this cancel out. Therefore, you have 1 over R equivalent is equals to 1 over R1 plus 1 over R2, right? So this is the formula which basically can give you the R equivalent for two resistors in parallel over here, right? Now imagine कि if I have multiple resistors in parallel, ठीक है? Let's say R1, R2, R3, right? And dot till my nth resistor here in parallel. This is R1, R2, R3, and Rn. So how do I find the equivalent resistance of this? Just apply this formula which you have derived before, right? Which is this one, right? So क्या हो जाएगा? This would be 1 over R equivalent is going to be simply 1 over R1 plus 1 over R2 plus 1 over R3 plus dot till the last resistor you have in parallel, right? ठीक है? This is basically the end of proof, right? If this makes sense, give me a thumbs up. The series and parallel combinations. Okay, it makes sense to me, Varta. That's good, right? So now, since it makes sense, I'm gonna test your concepts here, right? So let's do a summary first and a question, right? So this is summary of properties of parallel circuits, which we have learned now. That sum of currents in the branches of a parallel circuit equals the current entering or leaving this parallel selection. So it's just the KCL here, which we have learned, right? And this is the formula for finding equal resistance for resistor in parallel, right? Right. If the lamps are connected in parallel, which we have seen, the potential difference across each lamp is same, right? So the lamp shine with the same brightness, ठीक if irrespective of how many lamps are switched on. Each lamp can be turned on and off independently. So benefit of parallel circuits क्या है हमारे पास? So what is the benefit of parallel circuit? Let me just show you here. If I have a parallel circuit like this is a lamp one, this is lamp two. Let's say if this lamp is broken, right? So still my this lamp will blow, right? So this will not affect my operation of lamp one, right? However, in series, if you have any component broken, so that will break the path of current and everything will shut down, right? This is just a comparison between series and parallel circuits, right? So now, since we are done with this, now let's test our logic and the concept which we learned in the last set of slides, and let's see if we got them correctly or not, right? So you have a sort of a circuit on the top right of your screen, right, which you can see. You have a battery of 24 volts and you have three resistors over here, right? Okay. So let's see what do we have. We have potential difference 24 battery, right? And we want to find a combined resistance of 6 and 12 ohms in parallel, right? So we want to solve this particular thing out, right? So it's simple, right? So we have this configuration here. We have 6 and a 12 ohm resistor in parallel, and we know how to solve it out, right? You know the formula. This is 6 ohms and this is 12 ohms, right? So we want to convert this into a single resistor of resistance, basically R equivalent, right? So how do I find this out? I have the formula that 1 over R equivalent is equals to 1 over 6 plus 1 over 12, right? So if you solve it out, what do you get? Times 2 times 2. So it's going to be 1 over R equivalent is going to be 3 over 12. That is 3 ones are, 3 fours are. If you cross multiply this, so R equivalent is coming out to be 4 ohms, right? 4 ohms. So now you have this equivalent circuit which has a 4 ohm over here, right? So now let's write down your new circuit value here. So you have a 4 ohm and a 8 ohm resistor here, right? This is 24 volt battery and this is your R equivalent which has a value of 4 ohms, right? And this is the current flowing through the circuit here, right? So now they are basically asking in part B, this is part A which is solved, right? This is part A which is solved. Now for part B, they're asking, okay, what is the current flowing in the 8 ohm resistor, right? So they are basically asking you to find out the current flowing in the circuit, right? For this, I want to convert this again into a simple circuit such that I have this combination over here. I have a single resistor, okay, that is R equivalent bar, right? And I can find out the currents easily then, okay? Now I have two resistors in series, okay? I want to simplify them further. This is 12, this is 8 ohms, this is 4 ohms, right? So I can find its equivalent resistance easily. They are in series. So in series, the R equivalent bar is going to be simply the addition of the resistor in series. That is 12 ohms. Okay. This is now 12 ohms here. And this is the V is 24 volts. I can apply simply Ohm's law right now. So V equals to IR equivalent bar to find out I. So my I is going to be V upon R equivalent bar. So it's going to be 24 upon 12. So my current flowing in the circuit is 2 amperes. Right. So I hope it makes sense. Okay. So now this is the circuitry over here which I have now. Okay. So now let's solve for part C. Okay. So now you have this circuitry here, right? So I have the 8 ohm here, right? 4 ohm here and the 8 ohm here, right? This is 8 ohms and this is 4 ohms. And this was my R equivalent right now. And I निकाल चुका हूँ from my last part, that is 2 amperes. I know the battery, that is 24-volt battery. And my part C is saying, okay, you want to find out the potential difference across the parallel network, right? So let's say if I place the voltmeter here, what voltage value will I get here, right? So I have converted this circuit into this, right? So if I find the voltage drop across this particular R equivalent, that is going to be same, right? Because we have two resistors in parallel here. So the voltage across 4 ohms is going to be the voltage across 6 and 12 ohms, right? If this point makes sense, give me a thumbs up. Okay, if I find the voltage across 4 ohms, this is simplified form, right, of two parallel resistors. So that is going to be same voltage across 6 ohms and the voltage across 12 ohms because they are in parallel, right? If this makes sense, give me a thumbs up. It makes sense to me. What about Vardha and Hamza? Okay, it makes sense to Hamza. I believe it is clear to Vardha also. Okay. So I can simply basically find out the voltage drop across this to find out the voltage drop across these two set of resistors, right? Because they are in parallel. जो इन पे वोल्टेज ड्रॉप होता है वो सेम होता है, राइट? सो जो मैंने सिंप्लीफाई किया था टू इन दोनों को इन पैरेलल के अंदर आई गॉट 4 ohms. So if I find the overall potential difference across drop across this, that is going to be giving me a value of this voltage, right? So that is across the two branches over here. So since they are in parallel, it's going to be same, right, for both of them. But then now it made sense. Okay, ठीक है, good, right? So we basically went from here till here, ना? ठीक है, that is the reason. So now let's find the voltage drop across 4 ohms, right? V 4 ohms. So इसके लिए I know the current flowing through the components, right? That is I. मैं I निकाल चुका हूँ. I know the resistance of this equivalent resistor, that is 4 ohms. I can find out the potential difference across 4 ohms simply, right? That is going to be I flowing through the circuit times resistor 4 ohms, right? That has a resistance of 4 ohms, right? So simply put in the values to get your answer. So I is 2 ohms, the resistor is 4 ohms, the equivalent value of the resistor is 4 ohms. So it's 8 volts drop across these set of branch, right? So this basically has a drop of 8 volts here, right? And since they are in parallel, this particular branch also has a 8-volt drop on each other over here. They are in parallel voltage remains same, right? So this is your answer for your part C, right? So what is the answer for you now? Part D. Now what is the part D saying? They are saying find the current in the 6 ohm resistor. right? What is the benefit of we basically simplify the circuit first? Now we're basically breaking it up. We're basically going back to the original circuit again. Okay. So now they're saying what? Now they want to basically do this. For part D, okay. So we basically had this circuit before, right? So we went from here till here. Okay. So we found out the values of the unknown here, right? You know the current flowing through the circuit, that is 2 amperes, right? We know the potential difference across this parallel branch, that is now 8 volts, right? And this also has the 8-volt drop here, right? So now it is saying you want to find out the current. You know that current enters basically this particular node and is going to divide into I1 and I2, right? So we have found out the voltage drop across these set of parallel resistors. You know the resistance values also. So we can find out the current flowing through the circuit also. Okay? So we can find out by as follow that V 4 ohms जो मैंने निकाला था is going to be I1 times the resistor 6 ohms, right? So just basically put in the values. The voltage drop across this resistor is 8 volts, right? And the current one that is flowing in this branch is unknown, and the resistance value is 6 ohms here. So I can find out the current as follows. That is going to be 8 upon 6. So it's 2 4s are 2 3s are. Okay, so it's 4 upon 3. That is 1.3333 ampere, right? So it's 4 upon 3 amperes that is flowing in this branch. Okay, so that is answer for this. That is answer for this. Okay, so if it makes sense, how do you solve this question? So this is a typical exam type question, right? So you tested all of your concepts here, right? So if it makes sense, give me a thumbs up. Okay, it made sense to Hamza. Zabardast. What about Varda? Okay, good, right? So now the last topic over here, and then we'll end up the lecture, right? That is a potential divider. Yeah, we did this in the last lecture in the question number 1, right? So let's see how do I basically derive this formula here, right? Okay. So we learned this formula in the last lecture, that potential difference. Let's say if you want to find out V2, right? That is the drop across this resistor 2, right? You simply find this out by basically this following formula. The resistance of that particular resistor divided by the sum of all the resistor in series, right? Times the total voltage of the battery, that is V, right? You want to find out V1, that is going to be what? V1 is going to be the resistor जिसके across हमने voltage निकालना है, right? That is now VR1 divided by the sum of resistors that are in series. ठीक है? Add them all of them times the V here, right? This is the formula which we learned here, right? So now let's derive this relation over here. Okay, how do you derive this formula, right? Okay. So if I want to convert this circuit, let me insert a blank slide here and then we'll derive this together, right? So let me just copy this picture here and go there. Okay. So now we basically want to find out the current, right? So for finding out the current in this circuit, I want to simplify the circuit as follows. Okay. I want to get a single resistor here, right? As R equivalent, right? Okay. If I know R equivalent, I know V, I can find out current easily, right? So what is my R equivalent? They are in series, right? So my R equivalent therefore is simply what? It is simply what? It is R1 plus R2, right? If I want to find out my current flowing through the circuit, okay, my current will be what? My current will be, you can use Ohm's law. Ohm's law is V equals to I R equivalent, right? If you want to find out current, that is going to be simply V upon R equivalent, right? So we can also put in the value of R equivalent here. So my current flowing in this circuit is V upon R1 plus R2, right? So now you know the current flowing in the circuit, that is V upon R1 plus R2, right? So if you want to find out the potential difference drop across this resistor R1, right? That is V1. So you want to now apply basically what? The Ohm's law again, right? So apply Ohm's law, ठीक है. So Ohm's law says what? That V1 is going to be I times R1, right? Because you want to find the voltage drop across R1, तो आपने current flowing through a circuit that is passing through a component is I, ठीक है, times the value of the resistance that is R1 और multiply करेंगे तो you get V1, right? So let's put in expressions here. So my V1 is going to be what? My I is this, right? My I is this, ठीक है. So now just put in the expression over here, you get that R1 times V over R1 plus R2. Okay. So if you simplify this further, you get the relation that V1 is simply R1 upon R1 plus R2 times V, right? So it simplifies your calculation here, right? Instead of finding current first, okay, and then multiple using Ohm's law, you can directly apply this formula over here, which we learned, right? This is the summary of the derivation here. You can just use this formula, which is basically derived using these relations, right? And that should give you the exact answer which you want, right? So if this derivation and the formula of potential divider makes sense, give me a thumbs up. Okay, it makes sense to Vardha Hamza. That's good, right? That's good. So now let's quickly solve the question here because I have class in 10 minutes. Okay. So now we have two resistors in series, right? That is R1 is 80 ohms, R2 is basically 40 ohms here, right? They're saying you find the ratio of potential differences across the resistors here, right? So it's simple, right? So they are saying कि आपके पास दो resistor हैं in series. This is R1, this is R2, right? So the voltage difference, the potential difference across this is V1, the potential difference across this is V2, right? If you recall the formula to find the V1, okay, if my current flowing is I, okay, if I have battery V, right, let me fix this. If I have a battery which is basically V, right, so I can find V1 as follows. That V1 is basically what? R1 times basically what? I, current. And how can I find V2? I can find V2 as basically R2 times I, current, right? So current is same in both of the circuit, right? Because it's a series circuit, current is same in the circuit, right? Current is going to be same, current is going to be same, right? So I can basically make I subject in both of the equations. This is equation 1, this is equation 2. So let me make equation 1 can the I subject. So it's going to be I equals to V1 upon R1, right? And in equation 2 is going to be basically V what? Is going to be V2 upon R2. So I can equate these both currents here, right? So I can equate these two currents here to get my answers. So I equals to I, okay, that gives me that V1 upon R1 is equals to V2 upon R2, right? So this is the equation relation which we get for the voltage drop and the resistance, right? So let's see what do we have here. We have that V1 upon R1 is equals to V2 upon R2. Let's rearrange them. Okay, they want us to find out the ratio of the potential differences of V1 upon V2, right? So let's rearrange them. Let's cross multiply, right? So we'll get V1 upon V2 is equals to R1 upon R2, right? Let's send this over there. Okay. Let's send this over there and this over there, right? This over here. So it basically gives you the following formula, right? So you know the resistance values which is given to you. That is R1 is 80 and R2 is 40, right? So therefore, V1 upon V2 is 80 upon 40. So the voltage drop difference ratio is going to be 2, right? It means that V1 is going to have a twice the drop as compared to V2. Yes, the answer is 2. That's good. Okay. So this is the complete step over here, right? So we have derived this formula also and we have solved it out also. Okay. This is the derivation part here, right? Acha, Deep. So let's do the last part over here. So if the voltage supply is 24 volts, what is the potential difference across each resistor, right? So now they are saying कि आपके पास बैटरी हो गई, आपके पास you have a battery here, right? You have R1 here, you have R2 here, right? Right? R1 is 80 ohms, right? And R2 is 40 ohms. ठीक है, this is 24 volts. It is saying कि आप जल्दी से निकालें what is the V1 value here, what is the V2 drop here, right? Simply apply the potential divider formula. The V2 is going to be what? It's going to be R2 upon R1 plus R2 times the V of the battery. So R1 plus R2 हम कर लेते हैं जल्दी से. So it's basically 80 plus 40. It's basically 120 ohms, right? So now let's really say, find out V2. The V2 is 80 upon 120 times 24. So this 0 cancels out. 2 4s are, 2 6s are, 2 2s are, 2 3s are, 3 1s are, 3 8s are, 2 8 is 16, right? 16 volt is here, right? The V2 is basically having a drop of 16 volts, right? Let's find it out for uh, V2, right? So this is V2. Let's find V1 बोल के, ठीक है? Let's find V1. So V1 is going to be what? Going to be 80 upon 120 times 24, right? ठीक है? So it's 0 cancel out. Uh, 4 2s are, 4 3s are, 3 1s are, 3 8s are 24, and 8 to the 16, right? अच्छा मैंने यहाँ पे V1 निकाल दिया है मैंने, ठीक है? यहाँ पे मैंने V1 निकाल दिया है, सॉरी. दिस इज V1 here. हाँ, दिस इज V1 here and this is basically R1 here. ठीक है. ठीक है. हम्म. So this is 16 volts here and if you want to find out V2, ठीक है? So V2 is going to be what? V2 यहाँ पे basically I will have 40 here, right? I have 40 here. It's 40 upon 120 times 24. So 41s are, 43s are, 3 1s are, 3 8s are. So V1 is basically 8 volts. And you can still find out के अपन if you want to find out the V2 upon V1 ratio. So it's again 16 upon 8. It's again coming out to be 2. So you worked it out using calculation before using the correlation. KVS came out to be same, right? The ratio is same over here. So there was also another approach for solving this question here. Okay. So you got basically V1 here, right? So you got V1. You also apply KVL here to find V2, right? KVL क्या बोलता है? KVL बोलता है कि V is equals to V1 plus V2. You know you know V1, you can find V2 easily. So V2 is going to be 24 minus 16. That is again 8 volts, right? So that is the answer here, right? So now we'll basically just learn some sensors over here, some type of sensors which are used in industry and applications using the property of resistance. Some depends upon light intensity, some depends upon amount of heat. Okay, some depends upon basically polarities over here. So we learn these sensors in a while, right? So I hope that now everyone is in loop. जो last time नहीं आए थे, I guess they are also in loop. मैंने रिकॉर्डिंग्स लास्ट वाली अपलोड इसलिए नहीं की थी सो दैट एवरीवन कैचेस अप इन द लाइव क्लास. ठीक है, सो डोंट टेक द रिकॉर्डिंग्स एज अ बैकअप ऑप्शन कि आई कैन मिस द क्लास एंड आई कैन वॉच द रिकॉर्डिंग, राइट? सो आफ्टर द चैप्टर एंड्स आई विल अपलोड ऑल द रिकॉर्डिंग्स, ठीक है, सो दैट आई कैन रिवाइज बिफोर द नेक्स्ट क्लास. ठीक है. You will have one extra recorded lecture after tomorrow. तो संडे लेक्चर के बाद we will have one more lecture which you can watch during Eid. ठीक है. I don't want you to watch those during your Eid vacations, but we have our next class on Friday. I will update the timings also because Ramadan has ended. So we'll follow our regular timings जो हमारी पहले थी. So before that, you should watch that particular lecture, right? Because in the week after Eid, we finish up all the content. Okay, so I will be speeding up. So don't forget to catch up in the from the last content over here, right? Then we'll start having yearlies and I will have small test of you guys जो हमने chapters cover किए हैं. After the mid mock you will have a test in chunk, let's say 3 chapters test and then followed by 3 another chapter test. ठीक है, so that I can start revising the content. ठीक है, so let's begin with today's lecture. So what is the plan for today? We will finish the chapter and we'll do question answers of this particular so chapter over here. ठीक है, so sensors क्या होते हैं हमारे पास? What are sensors, by the way? Can anyone tell me what are sensors? What are sensors? Anyone? Give me a guess. What
To defect something.
to detect something? Yes, that's good. So basically, sensors are the components which basically detect the environment over here, right? So imagine this: okay, you have a block. Okay, we have a comment here. Machines that detect a particular object. Yes, they can be machines also. They can be simple single components also, right? Uh, so basically, what is happening over here? This is basically the environment, right? So basically, what does sensor does? Sensor detect the environment and basically gives you an output, right? So this is the functionality of a sensor over here, right? This entire thing is sensor. So they basically detect the environment over here depending upon the conditions of the environment. They give a certain value over here, right? We don't want to specifically go towards that what values does it give, how do we create hardware of this. Okay, just you should know okay, what are these sensors and how do they, what are the physical basically principles of operation. That's it. Right? It's just theory. So we have two major chunks here, that is thermistor and LDRs. Okay, we'll learn these in detail in a while. So these are two sensors in your syllabus, thermistors and light dependent resistors. Okay, so thermistors operate by sensing heat, right? And LDR basically they sense light intensity. Right, so these are the two sensors which you will learn over here. You learn the circuitry also, how do you create the circuit of this particular, and how what does it basically operates upon, right? So they can be used as input sensors in a circuit to detect changes in the environment over here, right? So these are sensors over here. So we're starting with the LDR first, light dependent resistor. So before starting, I'm going to quickly show you how do they look like. So this is the diagram A. This is the actual hardware package, right, which is available in the market. They're not so expensive. It is only of 5-10 rupees, right, each sensor. And this is the circuitry over here, the electrical circuit, right? This is the circuit representation here, right? And this is a symbol of LDR, right? This is the circuit symbol of LDR, right? It's a resistor, it's a box, and two arrows basically are incident upon this. So this basically shows light, right? That light is incident upon the LDR here, right? So how do you operate this? Okay, so now let's start learning LDRs over here. So the action of LDR depends upon the fact that the resistance of the semiconductor cadmium sulfide, which is basically is the material used to create LDRs. So its resistance decreases as the intensity of light increases over here, right? So this is the relation of resistance and light in LDRs. So this is the relation. If I want to summarize this in a single equation, it's going to be as follows: that light intensity is inversely proportional to the resistance of LDR, right? So as the light density increases, the resistance of the LDR decreases over here, right? So this can basically detect if you have high amount of light, so if the resistance drops, you can just directly relate okay, now light intensity is increasing. That is why resistance is dropping over here, right? So the LDR and circuit showing its action is shown in figure 4.315A and B. Okay. So this is the basically the representation of circuit diagram of LDR in action. So you have basically a voltage source, right? You have a voltage source over here. You have a lamp here, which is basically getting, which is displaying the light intensity over here, right? And this is the resistance in the circuit over here, which is dependent upon light intensity. So this is basically the thing which is you're controlling, right? Depending upon light. So if you increase the light, as the basic light density increases, the resistance of this particular block resistor decreases, and the lamp will glow more brightly, right? Because if you recall the Ohm's law says the following thing, right? That V equals to IR. If you decrease the resistance of the circuit, okay, so what would happen if I relate the current and the resistance? Okay, the current in the circuit is linked as follows over here, right? So if you decrease the overall resistance in the circuit, the current increases, right? And as the current increases in the circuit, the lamp glows more brightly, right? So that is how we control the light brightness of the lamp over here using LDR, right? If it makes sense, give me a thumbs up. That how does it operate? It makes sense to Hamza, ठीक है, Umama, Maeve, ठीक है. What about others? Varda and Mashal. Okay, makes sense to Varda. What about Mashal? Is it clear? I hope it is clear. If you have a question, you can ask me, ठीक है? The circuit symbol for LDR is basically sometimes seen with a circle here, right? So LDR का symbol क्या होता है हमारे पास? Usually it is basically this. Just imagine this. It's a resistor, and we have two arrows on this over here. This is LDR symbol over here, ठीक है? So LDRs are used in photographic exposure meters and in series with the resistor to provide an input signal in switching circuits, such as light operated intruded alarm over here, right? So these are basically application. This is an application of LDR. Okay, when can it be used? So let me just create a sketch over here. Okay, what are they showing over here? Right? Imagine you have a door, right? Imagine you have a door, okay, and you have a LDR sensor here, right? So let's say there is no person over here that is crossing the boundary of the door, right? So the LDR will show a constant resistance, right? Because इस पे जो light पड़ रही है, that is constant, right? And that is not going to vary the resistance over here. As soon as the person basically tries to cross the door over here, so it is going to block some light, right? And the light has a relation of the with the resistance of the LDR. That is as follows. Okay, if you basically let's say have a darker shadow over the LDR, that is going to decrease the light density upon it LDR, and the resistance is going to go higher, right? So this can basically send a signal, okay, to basically sound the alarm, right? And then your person can know, okay, if there's any intruder in your house or not, right? So that is how sensors work, right? So they have applications over here, and they can be used depending upon the type of application here, right? So I hope it makes sense, right? So these are sensors. So these are sensing the environment over here, and depending upon the environment conditions, it gives you a signal. Okay, it makes sense to Mama. That's good. Okay. Okay. If you have questions, please raise your hand. Okay. Otherwise, I'm going to move on. This is the application over here, and this is a simple circuit, right? That is intruder light intruder alarm circuit over here. So what is it showing here? So as it going to basically, this is the resistance of the LDR here. This is a fixed resistance, right? So as it basically varies, as it increases or decreases, it's going to basically cause the relay to activate, okay, and that is going to basically alarm the bell here, right? And that is going to send sound to basically the people or the police that if anyone is here, that is basically not required to be here at this particular amount of time, right? So that is how you can create a circuit that is going to be used as security alarm circuit, okay? So this is a simple application of LDR which you can see in real life, right? Okay, so let's move on. Now you have thermistor, right? Thermistor is basically what? Okay, it is basically a sensor also. Okay, and it basically works upon what? It detects thermal energy, right? Thermal energy, right? And what is the relation of a thermistor with thermal energy? It is as follows. Okay, thermal energy is inversely proportional to again the distance over here, right? So we are going to be only interested in negative temperature coefficient thermistor over here. इसकी property क्या होती है? If thermal energy increases, if the amount of heat energy that is basically sensed by a thermistor increases, the resistance of the thermistor drops, right? So it's a negative coefficient. That means it's an inverse relation over here. To draw the graph of this relation, that is going to be as follows. This is the resistance over here. This is the heat on the y-axis. To sketch a graph, it's going to be inverse relation, right? That is saying that if you increase the thermal energy, the resistance is going to drop, right? And vice versa, right? This is the relation of thermal energy and thermistor. So what is the relay circuit symbol of thermistor? It is as follows, right? This is the electrical symbol over here, the circuit symbol that you can use. Sorry, that you can use basically to create a circuit. Okay. The temperature may rise either because the thermistor is directly heated or because the current is in it, right? So the resistance decreases as the thermal temperature increases over here, right? This is the negative temperature coefficient thermistor in which you will be interested for your course only. And this is a symbol over here which you can see, okay, that if you want to represent a thermistor circuit, or if there is MCQ in your exam that asks that which one is the thermistor, so you should be able to recognize this using the symbol over here, right? We have some again some hardware demonstration. Okay, how does it look like in practical life, right? And what applications does it have, right? So if similarly following the trend of LDR, this is the hardware representation. Okay, that is the actual component that is found in market, right? As this is the thermistor over here, and this is the electrical circuit, okay, of the thermistor, right? And again, what does it have? It have a source, right, which is providing 6 volt DC voltage. It has a thermistor, okay, which is sensing heat, right? It is sensing heat over here, and this is the lamp over here, which is going to basically dictating if your resistance is varying or not, right? And the current flowing in a series circuit remains same. That is, the current is going to decide how bright is going to glow, right? Again, what is the relation of thermistor and energy? This is the relation over here. The temperature is inversely proportional to, let me call it R, right? Inversely proportional to R over here, right? And using Ohm's law, if I try to relate the current and the resistance of the circuit, it's again inversely proportional here, right? We have these two relations over here, which is going to basically dictate that how does it operate, right? Let's start. Let's say if you increase the temperature, let's say if there's a sensor at the gate of your door, which is detecting heat energy across my door, right? Obviously, a person has basically 37 degrees Celsius body temperature, normal, okay? So obviously when it's going to be around the door, around the sensor, the heat surrounding the sensor is going to increase, right? So as soon as the temperature increases, the resistance of this particular thermistor drops. And as the resistance drops, okay, the current in the circuit increases, right? As the current increases, the brightness will increase, right? So that is a simple circuit to basically learn about the properties that how does it work over here, right? If this thing makes sense, give me a thumbs up. How does thermistor operate? It makes sense to make
Sir, can you repeat the sum up of thing of the thermistor you did?
from here.
Yeah.
Okay, so is it clear that thermistor relation is basically inversely proportional, right? So if the temperature of the thermistor TK increases, the resistance of the thermistor is going to decrease. Does that make sense? This is a property. Okay, how is it created over here? This is the Ohm's law here. We are deciding here how is your current in the circuit going to vary. That is this. Current in a series circuit remains same. ये आपको पता है, right? So if the overall resistance of the circuit decreases because ये कम हो रहा है, तो overall R equivalent कम हो जाएगी. So the resistance drops. So if you basically make I subject over here, it's going to be V over R, right? So what is the relation between the current and the resistance of the circuit? It is as follows. Okay, the current in the circuit is inversely proportional to the overall resistance of the circuit. So if your resistance is dropping over here, the current flowing in the circuit increases. Okay, if the current increases over here, the bulb is going to glow more brightly because it is getting more current, right? Does that make sense? Mama? Okay, it makes sense to Hamza. Mashal, ठीक है. Maeve also. What about Varda and Mama? Okay, good. Right. Again, it's pretty similar to LDR. ठीक है. LDR में क्या हो रहा था? LDR में if you recall, वहाँ पे लाइट की इंटेंसिटी हम लोग सेंस कर रहे थे. So light intensity बढ़ी, resistance of the LDR decreases. Similarly, the overall current basically is going to increase and the lamp is going to grow. Oh, sorry, glow more brightly. यहाँ पे सिर्फ क्या हो रहा है? डिफरेंस क्या है? यहाँ पे हीट सेंस कर रहा है समझ. Thus, the working is same as basically of the LDR, right? So again, what is the application of this thermistor? You can use this in your security alarm, right? home security alarm system. You can even use this, you can or even make this on your own. Okay, just buy thermistors. It's also very inexpensive. Okay, it's cheap. Going to be maximum of 200 rupees, right? You can buy this on the market. You can create the circuitry over here, right? So it is usually used in home security system. Okay. So what is the circuitry over here? You have a battery source. You have a fixed resistor here. You have a thermistor over here, right? So what is going to happen as the resistance of the thermistor decreases? Okay. So there's going to be charging of the relay, right? The relay क्या is a switch. We will learn in a while relay क्या होती है. So it's going to activate the alarm. ठीक है. As let's say there's a person over here. There's a door here, right? And this thermistor is placed here. ठीक है. As the person crosses the particular thermistor, right, the temperature is going to rise and it's going to basically decrease the resistance of the thermistor here, which is going to activate basically the security system, right? And the bell is going to basically sound, right? And then a person can basically do the precautions, let's say call the police or uh, call the neighbors, okay, we have an intruder in our house or society, right? That is how it is used in real life application. Okay. So if thermistor makes sense, give me a thumbs up. If okay, it makes sense to Mehma, Maeve, Hamza. What about Varda and Mashal? Okay, makes sense to Mashal too. ठीक है, good. सही है. So let's move on. Let's move on to basically relays over here, right? So we have a closing topics here almost. So we have relays here, right? So what is a relay? Mashal is saying say कि sir are much thermistor used in fire alarms or in an area where specific heat is needed to maintain. Yes, Mashal, they are used in fire alarms. Thank you for identifying this. Fire alarm again when there is a smoke or there is a fire, the temperature is going to increase. The circuit activates and sound the alarm. Okay, that is good. Okay, I have a comment from Varda कि sir or something that connects to circuit, a wire maybe. Hmm, that's good. That's close. So imagine a switch. ठीक है? Imagine a switch. Let me take you back to our basics. Imagine a switch. You have a basically voltage supply, right? You have a let me draw your voltage supply जो आपकी actually होती है. ठीक है? You have a voltage supply over here. You have a switch here, right? And you have a lamp here. ठीक है? So this switch basically turns on or off, okay? Depending, it's a manual switch. You can turn it on and off. And current is basically going to flow when it turns on, right? So when the switch basically turns on, this is basically the off state, right? This is the off state here because switch is open. The switch is open here, right? And you can see that the path for the current to flow is not complete, right? So there is no current that is going to flow in the circuit over here, right? So the lamp is not going to shine, right? The lamp is also off, right? So it basically controls the flow of current. Basically turns on or off a circuit here, right? In this state, there is no current going to flow over here, and the lamp is not going to glow. Now, conversely, see this. Let me duplicate this. Now you have this condition here, which is basically the switch is closed. Okay, the switch is closed now. This is the switch I'm going to show here. Switch is basically closed. That means okay, now if the current starts to flow, it has a complete path to flow around the circuit and come back to the battery. In this configuration, the lamp is going to basically shine. Why? Because the current is flowing in the circuit, the lamp is going to glow. Okay? This is how you basically operate a switch. This is how the switch operates here. Now, what is a relay? If you don't want to basically operate the switch manually, right? Because you're operating is manually, right? You're manually. आप उसको open कर रहे हैं फिर close कर रहे हैं ठीक है to basically turn on or off the lamp over here, right? So now if you don't want to do it manually, you can use a relay, right? What is a relay? It basically has two circuits. ठीक है? This is called the magnetizing circuit. Magnetizing circuit. ठीक है? And this is basically the application circuit over here. application circuit. Imagine this. Imagine this. Okay, now you have basically, let's say, a huge building to power up, right? You have a huge building to power up, right? And you want to basically, let's say this is the supply coming from the electric or the any power production company, right? That is coming to the building, right? You want to basically, let's say, do some load shedding here, right? That happens in Karachi. Okay, you want to do load shedding here, that is turning off the power for some hours to basically do recovery, right? So you cannot open this manually, right? Because it is operating at 230 volts, right? It's containing huge amount of currents. And if you get, let's say, if you try to do it manually, there might be a huge spark which can basically electrocute you and kill you, right? So you want to do this automatically, right? Over here, you can use a relay, right? So what is a relay? It is basically a switch, right? Which works on magnetism, which works on magnetism. How? Let's check it out. Okay, let's check it out. So this is a circuit over here. So you have two circuits over here. One is the magnetizing circuit. Okay, the other is the actual application circuit over here. Just like imagine a building, right? Building, you want to power up the building over here, right? So what happens actually, we can basically close this switch here, right? Which is operating at only 5 volts, right? This appliance is basically working on 230 volts, right? So if you want to basically control an application which is operating at high power, so you can create a relay which operates on very low power, right? For safety of your operation here, right? So what happens as soon as you basically close the circuit switch over here, this basically flows a lead towards the flow of current, right? This is a sort of a coil here which magnetizes, right? It's a coil here which produces magnetism, right? And this is basically made up of magnetic material, right? As soon as it magnetizes, it produces some poles here, let's say north or south pole. So this basically induces a pole here also, a south pole, which creates a force of attraction basically, and it basically closes off the switch here. And this particular supply is also activated and the current flows through this also, right? This basically, let's say, power up your building. Okay? So there is building over here, which gets the electricity over here. Let's say if you want to, let's say, do load shedding, you can simply basically do what? This building is powered up. Now, let's say if you want to close their power, you can simply do the following. You can simply remove the small circuit, the magnetizing circuit electricity. Okay, you can simply again make it open. So there will be no current flowing in the circuit, right? So there will be no force. There will be no magnetism in the coil. There will be no poles here. So there will be no force that is going to basically close the circuit. And hence this particular going to, this switch basically turns off again and it leads towards no flow of current and the building basically is now powered down, right? So that is how this relay operates here. If you want to control an application which is operating at high power, I don't want to basically do it manually, so you can use a relay which basically works on magnetism. So relay has a small circuit which operates at 5 volts only. You can control that using a manually or using Arduino board or any basically microcontroller. I can basically do this phenomena over here that is shutting down the high power application on or off, right? So let's now read the skim the theory over here that can be summarizing the discussion over here, right? So a switching circuit cannot supply much power to an appliance. So a relay is often included over here. This allows the small current provided by the switching circuit to control the larger current needed to operate ठीक है a buzzer or any application which requires high amount of power, right? So relay is controlled by a switching circuit, can also be used to switch on the main supply for electrical appliances in the home. Let's say if you want to operate refrigerator, right? You want to automatically operate refrigerator depending upon your relays ठीक है automatically you can use a relay over there. You don't have to go towards your refrigerator and do it manually, right? So this is the figure 4.3.70, which we just discussed in detail. So they're just saying कि how does it operate over here? So you just need a small current using a 5-volt battery to control the main switch over here, which is operating at 230 volts, right? So what is the benefit of this? It isolates the two circuit, right? The low voltage circuit from the high voltage circuit. So there can be no cause of, let's say, fire also, okay? And no scenario of getting shock from the main supply if you're doing it manually over here. So that is how relays are beneficial, and that is how they are used in the actual industry over here. They are used widely, by the way. Okay, they're used for protection, right? Let's say if you want to protect your expensive microcontroller Arduino board, okay, from getting burned, so you can use a relay over here because no current flows from relay to this coil, right? It use basically induced magnetism to basically operate this particular switch over here, which basically does what? Turns on and off the building, right? So if it makes sense, give me a thumbs up. How does our relays operate? If the operation of relay makes sense, give me a thumbs up. It makes sense to me. If okay, Hamza, that's good. What about Mashal and Mama? Okay, makes sense to Mashal also. I believe Umama is here. Okay, good. सही है जी. So now we have light emitting diode. ठीक है. Again, you might have seen this multiple times, take care in your labs, and you have seen this multiple times when you're, let's say, turning on treadmill. You see digits basically counting your kilometers ran. ठीक है. So it's just an LED. ठीक है, which is shown like this. ठीक है. It has two terminals. ठीक है. One is called the cathode. ठीक है. One is called the anode here. You know anode क्या होती है? Positive होता है हमारे पास. And one is called the cathode, and cathode is the negative terminal over here. So light emitting diode LED is basically contains terminals which have to be taken care of while connecting in the circuit here, right? So an LED showed in figure 4.3.18a, that is this, right? Is a diode made from semiconductor gallium arsenide phosphide. Okay. When it is forward biased, okay, the current makes it emit red light, yellow or green light depending upon the current of color of your LED here, right? So you will learn इसके बाद diode क्या होते हैं. Just learn that this is the symbol of LED, right? This is the circuit symbol over here. If positive of the battery is connected with the positive of the, this is a positive of diode LED over here, this is the negative of your LED. So if positive of your battery is connected with the positive of your LED and negative of your battery is connected with the negative of the LED, this will allow the current to flow in the circuit, and this basically leads towards glowing of the LED here, depending upon the color. Okay, can be yellow also, right? Let's say it is yellow. It gives off yellow light here. Depending upon the color of your LED, it gives out the color over here in this particular configuration here, right? If it is connected vice versa, opposite, let's say if it is connected like this is the battery here, this is the positive, this is the negative. If you connect, let's say this is a resistor for protecting the LED. If you connect it like this, and this is the symbol of your LED. This is the LED here, this is the resistor for controlling the amount of current so that your LED. Acha, now if you have this particular configuration here, you can imagine this. Now we have what scenario here? The positive of the battery is now connected with the negative of the LED. So if you just recall the symbol of the LED is as follows. Okay, with two arrow. This is positive of the battery. Oh, sorry, LED. This is positive, negative of the LED here. So now the LED is off, right? So in this configuration, the LED is going to be off. Why? Because now the positive of the battery is linked with the negative of the LED, and the negative of the battery is linked with the positive of the LED here. So there's no going to be current flow in the circuit over here, and this LED is going to be off here, right? So the polarity is very important in this configuration, in this case of LED. Okay. So this is an LED over here, and we basically have seen this multiple times. If you basically see a digit counter over here, a digital, let's say clock or a watch, which is showing you time. They contain basically multiple LEDs over here. Okay, so we have LED one, two, three, four, five, six, seven LEDs are basically showing a digit over here, right? So you have seen this case zero is shown as this, one, two, three, four, five, six, seven, and nine over here, right? So you can control the amount of color depending upon the material, the chemical, the element which is used to create the LED over here. Okay, so some material gives off red, some basically gives off green light, some gives off blue light over here. Right? You combine all of them together to create white light also. Okay, and so on and so forth. So the last topic which we're going to cover over here is going to be a diode, right? So this is the last topic which we cover, and we'll end the lecture over here. So diode is basically what? It allows the current to flow in only one direction. Okay. If you recall this, it is pretty similar to LED, but diode does not glow. Okay. So let's see कि what is the diode electrically, and then we'll cover the theories के बाद. Okay. So this is the symbol of the diode. The symbol of the diode is as follows. It is just very similar to LED, but it has no arrows over here, right? This is a symbol of the diode here, and it has also poles. This is positive, this is negative here, right? So let's see the circuit of a diode in which diode is conducting, right? Let's draw two circuits here. So we have a battery here, and then we have, let's say, a resistor here, a diode here, okay, and a lamp here, right? This is a resistor, this is a diode, this is a lamp here, this is a battery over here, right? Now we can see, acha, this configuration is called forward biased. Forward biased, right? So only in this configuration, the diode will conduct current over here and the lamp will glow. Why? Because for forward biased kind of configuration, we want the positive of the battery to be connected with the positive of the diode and the negative of the battery to be connected with the negative of the diode. If this configuration is followed over here, the current will flow and the lamp is going to glow over here, right? This is called the forward biased over here. Right? Let me now draw some animation. So the lamp is going to basically glow. Okay, now see, let's see the other configuration in which the diode blocks the current. Okay, that is called the reverse biased. Reversed bias configuration. Okay, so similarly, we have the same circuitry. We have a battery. We have a resistor to control the amount of current. Now we have a diode which is now flipped, right? And then we have a lamp here, which is going to basically tell us if it is if there is current in the circuit or not, right? So we have the battery, we have the resistor here, we have the diode here, and we have the lamp here, right? So now the current is going to be zero here. That is, no current is going to flow in the circuit because it is reverse biased. When is it reverse biased? When the battery, when the positive of the battery is connected with the negative of the diode here, and when the negative of the battery is connected with the opposite positive of the diode here. So this is reverse biased. In this configuration, the diode will block the current. Okay, it will basically try to open circuit. Okay, it will break the path, right? It will break the path for the current to flow, and the lamp is going to be off, right? So this is going to be basically which saying the lamp is off. That means the current is not flowing in the circuit over here. So that is how basically diode operates. It has applications which is widely used in current world. It is used in applications in as in your chargers, right? So on and so forth, right? So now let's read the theory and let's make sense of it. Is it correct or not, right? So the diode is a device that basically allows or lets current to pass only in one direction. That makes sense, right? अगर आपको पता चले यहाँ पे, if you have basically, let's say, current flowing from positive negative, it allows only to flow when it is basically matching the polarity of the battery here, right? When the positive is same as positive of the diode. If the current is basically going to flow, let's say, in reverse direction, okay, but now you can see that the polarity of the battery is not matching this. Now it's going to block the current to flow, okay. That is saying that the diode only allows the current to pass when it is in this configuration here. In any other configuration, it will block the current flow over here, okay. That is the configuration, that is the main property of the diode over here, right? तो सिंबल आपने देख लिया है. हमारे पास यहाँ पे, that is as follows. This is the symbol of the diode here, right? And the wire nearest the band is the cathode, and the one at the end is the anode here, right? So this is basically the cathode here, right? The negative is just the line. Okay, the line showing the parallel line is basically the cathode of a diode. Okay, the negative terminal, and the other side of this particular side is called the anode, the positive side of the diode here, right? Then we have the typical IV graph, that how does it operate. If we basically we see this in a while कि कैसे करता है हमारे पास operate, right? So diode conducts when the anode of the positive terminal of the supply is basically connected with the negative over here, right? Right. So it is just saying कि हमारे पास कि when the positive of the battery is basically connected with the positive of the diode, this is the only condition in which the current will flow, and it will glow the lamp over here, right? Otherwise, it will block the current to flow over here, right? Uh, it is then forward biased. The distance very small. ठीक है. Conventional current passes in the direction of the arrow on its symbol over here, right? So it is just saying कि when it is forward bias, the current basically flows from positive to negative over here, in this direction only over here, right? So there will be no current passing in this direction, that is from negative to positive over here, right? So that is the property of a diode here, right? Now imagine this is the circuitry over here. So this is the circuit, the electrical circuit of diode work in progress. This is the electrical circuit. ठीक है. Just summarizing the understanding over here. You can now see that positive of the battery is connected with the positive of the diode. ठीक है. And negative of the battery is connected with the negative of the diode here. In this condition, basically the current flows, right? And you can see that the lamp is glowing over here, right? If you flip the polarity of the battery like this, let's say now the negative of the battery is connected with the positive of the diode, and the positive is connected with the negative. That is saying a battery is trying to push the current in this direction. So it will not allow the current to flow in this direction. ठीक है. That is, now the current will be zero in this particular configuration, and the lamp is going to be basically be off here, right? That is saying, conveying the message कि हमारे पास there is no current flowing in this particular configuration. Stating that diode only allows the current to flow only in one direction here. अब there might be a question कि sir, how is it used? Where is it used? ठीक है. That is a good question. So it is used as follows. Now imagine this. If you have, let's say, your supply that is coming to your house, ठीक है, it is AC voltage, right? It is a sine pulse, right? And you can see that हमारे पास in this configuration the voltage is positive and negative both, right? So if you have this circuitry here, let's say you have a AC supply, right? And you have a diode connected with this particular configuration here, right? So what would be the output of this if you basically measure the voltage across this diode using a voltmeter? What would be the output here? The output is going to be as follows, right? How? Let's check it out. Okay, if the positive voltage is flowing in the circuit, that means कि हमारे पास positive ये है, negative ये है. So this, in this configuration, the diode would allow the current to pass through. That is, there would be a potential drop across the diode. That is this, right? You can see that the positive cycle is basically passed through the diode here. But now what happens when the cycle is basically reversed, when you have a negative voltage? So that is saying the polarity of the voltage flips. Now the battery is trying to push the current in the opposite direction, right? In this direction. So this is going to be basically be blocked here. The diode is going to basically operate in reversed bias configuration. That is going to block the current. And you can see that in this negative cycle, the output voltage is zero. That is, the diode is not operating. Then again it repeats. The positive is allowed, the negative is blocked. Positive is allowed, the negative is blocked. Okay. So this particular operation of the diode is called rectification. Right? You can see that the input was AC. The output is now only DC. DC means what? It only allows the current to pass through in only one direction. Okay? You can see that overall voltage is only positive direction. Okay? Only positive. There is no negative output over here. That is basically you're converting AC voltage to DC voltage over here, and this phenomenon is called rectification over here, right? So these are used widely in basically inverters. ठीक है। एनीवे इन्वर्टर्स आर फाउंड इन एवरीवेयर। जैसे इमेजिन योर यूपीएस। ठीक है, यूपीएस क्या होता है हमारे पास, उसके अंदर इन्वर्टर होता है, राइट। इन योर हाउस यू माइट हैव अ यूपीएस सेटअप इन विच यू हैव दिस फॉलोइंग सेटअप ओवर हियर। आपके पास क्या होता है घर पे, यू हैव एन इन्वर्टर, राइट, एंड देन यू हैव अ बैटरी, right? In your house, you might have this, and this is the input which is from coming from, let's say, power company, right? Power company, which is a simply AC voltage, right? So in what battery basically needs DC voltage to charge, right? It needs this voltage over here, constant voltage to charge over here, right? So inverter does what? Inverter basically converts this wave to this particular wave over here that is going to charge up your battery. And let's say when there is no light at your homes, the battery is going to basically provide a DC voltage as an input to your inverter. It's going to convert this back to your AC wave, and this is going to be supplied to your house. This is going to be powered up, right? So that is how it is used in real life, and it is used basically rigorously. ठीक है, if you see every application in your house, you have inverter in every application, from electric vehicle to power production houses to your homes to your industries, so on and so forth, right? So that is the application of basically diodes here, and this basically leads towards the end of our chapter.